Dear class 10 student, we are going to start new chapter, that is chapter 5. The name of the chapter is Periodic Classification of Element. In class 9 we have learned that matter around us is present in the form of elements, compounds and mixtures, and the elements contain atoms of only one type. So we have already studied in matter around us in class 9. There are matters which are of some of them are elements, some are compound and mixtures. So out of this today we know only 118 elements. Okay, we know only 118 elements. All these have been different properties. Out of this 118 element, only 94 elements are naturally occurring. Remaining are artificial, man-made elements. As different elements were being discovered, scientists gathered more and more information about the properties of these elements. They found it is difficult to organize all that was known about the elements. They started looking for some pattern. Pattern is very important. Okay, in their properties, on the basis of which they could study such a large number of elements with ease. So scientists started, there are so many elements, to study the properties of this element. It was very vast, difficult. Okay, so they started thinking of a pattern which can with that pattern we can easily identify the element. So next we are going there to making order out of chaos. Chaos means making order from the haphazardly scattered things. Okay, that is called chaos. So making order out of chaos. Early attempt at the classification of elements. We have been learning about various things or living beings can be classified on basis of their properties. So various things or living beings can be classified on the basis of their properties. Even in other situations, we come across instances of organization based on soaps are kept together at one place, while biscuits kept together elsewhere. So some like soap is kept somewhere, biscuits are kept somewhere, and other things like rice meals and all, rice or dal, everything are kept separately but together. Okay, even amongst soaps, bathing soaps are stacked separately from washing soaps. Similarly, scientists made several attempts to classify elements according to their properties and obtain an orderly arrangement out of chaos. So they have, with the help of the properties, these properties elements are kept in this stack. Okay, and these properties of elements are kept in this stack. Like so, they started arranging the elements according to their properties. The earliest attempt to classify the elements resulted in grouping the then known element as metals and non-metals. First they started grouping metals and non-metals. Okay, later further classification were tried out as our knowledge of elements and their properties increased. So further classification was made when the knowledge of elements properties of knowledge of element were increased. The first trial was made by Dobereiner, and this trial was known as Dobereiner triad. This first pattern was given by Dobereiner and is known as Dobereiner triad. In the year 1817, Johannes Wolfgang Dobereiner, a German scientist, tried to arrange the element with similar properties into groups. He identified some groups having 3 elements each. So he called this group triad. Okay. So Dobereiner showed that when the 3 elements in the triad were written in order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic mass of the 2 element. So here we can write down Dobereiner showed that when 3 elements in a triad were in order of increasing atomic masses, the atomic 3 elements in a triad were written in order of increasing atomic masses. The atomic masses of the middle element was roughly the atomic 2. Okay. So here we can raise a question here. Write about a Dobereiner triad. Dobereiner, triad. Okay. So the question may be like this. So write about Dobereiner. You can write Dobereiner shows that when 3 elements in a triad were written in order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other 2. For example, take the triad consisting of lithium, sodium, potassium, okay, with the respective atomic number 6.9, 23 and 39. The atomic mass of lithium is 6.9, sodium is 23 and potassium is 39. So you take the average. If you take the average, the first and this last, if we add 69 plus 39, whatever we get, okay, let us find out. .9 plus 3.9, how much we are getting? And now divide it by half, 2, 5.4. Okay, let's do it again. Average will be what? 6.9 plus 3.9, 399, 39, sorry, there is a mistake I think. .9 plus 39 equal to how much? This much, divided by 2. How much we are getting? 22.95. Okay, it's okay now. Okay, 22 point, what was that? 22.95. So if you take the average, we get 22.95, which is approximately equal to 23, which is the atomic mass of sodium. Okay, given below, table 5.1 are the group of 3 elements. These elements are arranged downward in order of increasing atomic masses. Can you find out which of these groups form the Dobereiner? Okay, so you calculate the average. So 3 is there. Nitrogen, phosphorus, and arsenic. Nitrogen atomic mass is 14, phosphorus atomic mass is 31, and arsenic 35. Atomic mass is 74. So you take sum of 14, that is nitrogen, atomic mass of nitrogen and arsenic. What is that? Let's see, calculate again. That is 14 plus 74, which is equal to 88 divided by 2, 44. So it is this is, we are getting 44, okay, phosphorus according to Dobereiner triad. So I don't think this is a triad. Let's see. Let us take calcium. This is calcium, strontium, and barium. Okay. So what is the atomic mass of calcium? 40.1. Okay, plus 137.3, which is equal to 177.4 divided by 2. So I think this is the correct one. This is, so calcium, strontium, and barium is forming Dobereiner triad. Okay. Now next we go to chlorine, bromine, and iodine. Let us take it, this example. 35, first element is 35.5, and the iodine is 126. Sorry, we have to do it again. Plus 126. How much it is? 161 divided by 280. So it is approximately same. Here we are getting 80.75. Here it is according to the analysis, it was 79.9. So they are almost equal. So these two columns are making triad, whereas this is not making the triad. So you will find that group B and C Dobereiner triad could only 3 triads from the elements known at that time. So hence this system of classification into triad was not found. So Dobereiner triads are, okay, Dobereiner triads are this. You can write down this one. Okay, this is the Dobereiner triad. Remember it. Okay. Now we go to Newlands' law of octave. Okay. Newlands' law of octave. After that, Dobereiner triad was not successful because it was dealing with only 3 elements, and it is we have lot of elements. Okay. So at that time, how many elements were found? Let us see. John eventually. it is not mentioned here how many elements were there. I'll give it to you later on. So let's go to Newlands' law of octave. The attempt of Dobereiner Triad encourages other chemists to correlate the properties of elements with their atomic masses. In 1866, John Newland, an English scientist, arranged the then known element in the order of increasing masses. He started with elements having lowest atomic mass, hydrogen, and ended at thorium, which has 56th element. He found that every 8 element, okay, had properties similar to that of the first. So like you take for example sa, re, ga, ma, pa, dha, ni, sa. Okay, so the first element is starting with sa, and the 8th element is again starting with sa, ending with sa. So the first and the 8th element will be similar. Properties of the 8th element will be similar. Same way, the ray. Okay, let's do it from the book. He compared this to octave found in music. Therefore, he called it law of octave. It is known as Newlands' law of octave. In Newlands' law of octave, properties of the lithium and sodium were found to be same, and sodium is the 8th element after lithium. Similarly, beryllium and magnesium resembles each other. So if anybody asks you what is define Newlands' law of octave, what you will say? So you can start in 86 and the lowest and ended in thorium element. He found that every 8th element had the first up to here. Okay, this is right there. You can write fine, not define, explain, write about, you can write it, write about new law of octave. Okay, so question will be write about Newlands' law of octave. The answer is whatever marking I have done, yellow marking, that's up to. It is known as Newlands' law of octave in it is known as Newlands' law of octave. In Newlands' octave, the properties of the sodium in Newlands' law of octave, the properties of sodium found to be the same. Lithium and sodium found to be the same. Sodium is the 8th element after lithium, and beryllium resemble each other, as you can see in the table. See here. So 8th element, you count it. H, sa, re, ga. So H is your hydrogen. In the second, it is arranged in a atomic mass. Okay, increasing atomic mass. Okay, it it is arranged into its hydrogen is hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay, so hydrogen and fluorine will have the same property. Okay, lithium and nitrogen, sodium will have same property, beryllium and magnesium will have same property, beryllium and boron and aluminum will have just like this, and this all